Let's now summarize what we saw about propositional logic in AI. Propositional logic is a formal language to describe the world around us that can help an agent model the world. Sentences in propositional logic have a specific syntax with symbols and connectives that can form logical sentences. Symbols or terms can be either true or false or unknown. Logical connectives are the implication, the conjunction, disjunction, negation, double implication. And we actually like to use connectives to build more complex sentences. It's important to note that syntax and semantic represent two important and distinct aspects in propositional logic, and we have seen what the relationship between the two. Semantic represents the configurations or the instantiations of the word with truth values. We saw a very popular rule of inference called modus ponens that actually derives new knowledge based on existing knowledge, such as we have P1, Pn true, and the conjunction of P1, Pn implies Q, then we can infer Q. This is by what we call modus ponens. Modus ponens deal sometimes with horn clauses when we have the restrictions of the form of the clauses that are in the knowledge base. Horn clauses are logical propositions of the form P1 and P2, Pn implies Q. The inference, actually, we want some inference algorithm that is both sound and complete. Sound is when we want to infer only true formulas, and ideally complete when we want to find all true formulas. And we saw specifically the bridge between the two. The inference in propositional logic with horn clauses is sound and complete, and actually so is the resolution rule that we use to do inference. So propositional logic sounds like a powerful paradigm to represent knowledge about the world in AI. However, it has limits. First of all, propositional logic is not expressive enough to describe the world around us, including information about objects and the relationship between objects. It doesn't, for example, express also time. Also, propositional logic is not compact. In other words, if you want to express that there is a pit in all the rooms in the cave, we have to write that there is a pit in 1-1 or a pit in 1-2, etc., until a pit in 4-4. And you could imagine if you have 10 by 10 rooms in the caves, and we have to do that for 100, write 100 symbols to represent that. So PL is not compact enough. It can't express a fact of a set of objects without enumerating all of them, which is sometimes very tedious and sometimes impossible. So just to maybe you are tired from the example of the rumpus, I'm going to pick another example, which is the vacuum cleaner. Suppose we have a Roomba to clean a 10 by 10 square in the classroom, and we want to use propositional logic to express information about the squares. So to express that a square is clean, we're going to use the proposition square 1 is clean to express that the first square is clean. How can we write that in a less heavy way? We're going to express that all the squares in the room are clean as follows. Square 1 is clean, and square 2 is clean, and square 100 is clean. So that's a little heavy. We have 100 terms, the conjunction of 100 terms. Now, how can we express that some squares in the room are clean? We're going to put a disjunction. Either square 1 is clean, or square 2 is clean, or square 100 is clean. You can also want to, for example, express that some squares have a chair on them. In other words, square 1 has a chair, or square 2 has a chair, so it's going to become really heavy to express information about all the possible components in the word.